for microbiology for the step 1. And this is going to be really basic principles, so it's really applicable for step 2 CK and also for step 3. It's really basic principles, and it's from the first aid book. So we have here gram positive. So recall, guys, gram positive will stain purple, blue. We can divide these into three main categories over here. The three main categories are going to be gram bacilli, which are basically rods, and we can have filamentous rods, and we can have cocci. So bacillus, we're gonna have to remember four main bacteria. Okay, first is gonna be the bacillus cereus anthrax. Next is gonna be Clostridium, but guys, Clostridium is gonna be anaerobes. Then we're gonna have Corynebacterium, and the last one is gonna be Lactobacillus, Listeria. Sorry, Listeria. So we can see Listeria, Bacillus, Corynebacterium, Clostridium. We also have the Propionibacterium, but that's not very like important, not high yield. And we have a really nice mnemonic for anaerobic bacteria. So that's going to be can't breathe fresh air. So C as in Clostridium, B as in Bacteroides, F as in Fucibacterium, and A as in Actinomyces is really. And then we come into the branchy filaments. So you can call them branchy filaments, and they're going to be aerobic, which is going to be nocardia, which is usually weakly acid fast, and actinomyces really, which is not active fast at all. Active fast, by the way, guys, is basically like a stain that they use for tuberculosis. Basically, it's a stain to look at mycolic acid, and of course, the nocardia will have it because they have a little bit of mycolic acid, but actinomyces really, no, it doesn't have any mycolic acid, therefore it does not stain acid fast. The next page, you guys are going to come into catalase positive, catalase negative. Now, catalase, guys, is really important enzyme. Basically, it's found in many things, so humans, bacteria, fungi, plants, and this basically breaks down hydrogen peroxide into water and O2. And catalase is really important in organism for antioxidants, so it kind of protects the bacteria in that sense. We're going to be speaking, that's really important for when we speak about chronic granulomatous diseases. So catalase positive is going to be all your staph. And that can be divided also in two groups. So coagulase negative, coagulase positive or negative. So coagulase, guys, positive is basically an enzyme which catalyzes the conversion of fibrinogen, which is a soluble plasma protein, into a insoluble protein that forms the basis of the blood clot. So fibrinogen, which is really soluble, into fibrin, which makes that strong insoluble clot. That's going to be done here. So coagulase positive, catalase positive, staph aureus. Remember, aureus is positive for everything. And then negative, guys, is going to be your staph epi and your staph saprophagus. Now, how you want to differentiate the two? So that's going to be here with your novobiosin. So novobiosin sensitive is basically, novobiosin it's an antibiotic. We don't use it anymore, but basically it's there to kind of works inhibiting the DNA gyrase. Basically, it's a crucial enzyme required for DNA replication. So basically, this enzyme is very sensitive against staph epidermidis, but against saprophyticus, it's not sensitive at all. And then let's come back to the cocci, but let's come into catalase negative. So these are going to be divided into three groups, two bacteria each. We're going to start off with alpha hemolysis over here. So alpha hemolysis is going to be now divided into two groups of bacteria. One that are oxygen sensitive and bile soluble. So that's going to be strep pneumo, a very, very important bacteria for our pneumonia and meningitis and other stuff. And optichin, basically, again, it's a compound, and this was used to kind of help differentiate the two. And the other one is Streptococcus viridans, which has Streptococcus mutus, sanguis, which is going to be there for infective endocarditis. Let's come into beta hemolysis. So beta hemolysis means complete clear hemolysis, and this can also be divided into two main groups. One is going to be bacitracin sensitive, one is going to be PYR status. So bacitracin sensitivity is going to be basically antibiotic, and PYR status. PYR is really complicated. I kind of looked into it, but it was the pyridyl aromatase, also known as pyridyl aminopeptidase. Basically, it's an enzyme, bacterial enzyme that hydrolyzes the pyroglutamic acid. So if it's going to be positive, it's going to be group A Streptococcus pyogenes. If it's going to be negative, it's going to be group B Streptococcus agalactiae. The last group is going to be gamma hemolysis. This is going to be no hemolysis, and it grows on bile over here. So this is going to be, if it grows in 6.5% sodium chloride and PYR status, that's going to be our enterococci. So enterococci fecalis and faecium. And then if it's going to be negative, it's going to be our non-enterococcus Streptococcus bovis. If you come over here, it's basically repeating what we said over there above, how to differentiate the two types of staphylococcus. So staph epi from staph saprophagus, one is optician sensitive, one is not, which is saprophagus. But then we can come into optician or the bile solubility. So that's going to be our strep pneumo. The main one is going to be sensitive, whereas our viridans is going to be not sensitive, is going to be resistant. And then we can come into bacitracin and again PBR status. That's going to be sensitive for our group A streptococcus, but it's going to be negative for our group B streptococcus, resistant over there. So that was basically overview. I'm going to quickly recap that. So gram-positive organisms, we can just divide it into our bacillus, our cocci, and our filamentous branching filaments. And that's the way you want to branch it out and recall these really important bacteria for gram-positive. So guys, hopefully you guys found this video useful. Thank you for watching, and I hope to see you guys next time.